Okay, today we are going over 12.3, analyzing data. So when we're analyzing data, we're going to be looking at what's called the measures of central tendency. And this might be a new term for us, but a lot of what we're going to be going over today shouldn't be very new. We should know it already. So the measures of central tendency include the mean, the median, and the mode. Okay, and those are the measures of central tendency. So if you were asked to find the measures of central tendency, you would find these three values, the mean, median, and mode. So we're going to go over how to find those three. So here's an example that we have, and the mean is you're going to take the sum of all of the data values and divide it by the number of data values that you have. So the mean is also known as the average, and that will be denoted just like this. Okay, so we're going to go ahead and add all of these numbers up. 1 plus 2 plus 2 plus 3 plus 5 plus 5. And we're going to divide it by the amount of numbers we're adding. 2, 4, 6 numbers we're adding up, so we'll divide that by 6. The sum of that is an 18. Divide that by 6 and we get 3. That's our mean for this data sample. The median is the middle value, and it's the middle value when you have an odd amount of numbers, because then you can find the exact middle number. Or if it's an even amount of values, just like we have here, we have an even amount of numbers, we're going to find the mean of the two middle values. So the two middle values here are 2 and 3. And we should note that for the median, you have to order them so you have to order the values, and they have to be least to greatest. And that's for the median. Sorry, that says greatest. Really bad handwriting. Sorry about that. Okay, so after we order from least to greatest, if it is not already from least to greatest, this one is, you would take the two middle values and find the average. So you would add them and divide by 2. 2 plus 3 is a 5 over 2 is 2.5 or 2.5. Some of us can just use some mental math here and say the middle of 2 and 3 is 2.5. So if you can do it mental math for this, go for it. All right, the mode is the most frequently occurring value, the one that comes up the most. So the one that comes up the most here, we have a 2 that comes up twice, and a 5 comes up twice. So therefore we have 2 and 5 are going to be the modes. And this is actually given a name. It's called bimodal. When we hear the word bi, we should think of 2. So it's bimodal, which is a set that has 2 modes. All right, and that's mean, median, mode, which is the measures of central tendency. Moving on here, this one you would do the same thing, finding the mean, median, and mode for these. So right now they are not in order from least to greatest, so you would actually have to do that. So I went ahead and did that already. So I put them in order from least to greatest. And for the mean, we're going to add all these numbers up. So just to save a little bit of time, I already added them up, and the sum of those is 819. And we're going to divide that by, there are a total of 9 numbers here. If we count them, 2, 4, 6, 8, 9. There's 9 numbers here. 9 goes into 81 9 times. 9 goes into 9 once. So our mean is 91. Finding the median, which is when we have to order them from least to greatest, the median is the middle. Since we have 9 numbers, an odd amount, we'll have exactly one number right in the middle here. There's 4 below that, 4 above that. So the median of this set is 95. And the mode, the one that comes up the most, is we have 2 97s, so the mode is 97. Okay, moving on here, we're going to be looking at quartiles. So by arranging the data in increasing order, the median divides the data set into 2 equal parts, right? We'll get the median, the middle of the set, and then we'll have the the lower part of the set, and we'll have the upper part of the set. You can use the median of each of the two parts to divide the set further into 4 equal parts. So we'll have the lower part, find the median of that. We'll have the upper part, find the median of that. The values separating the 4 parts are called the quartile. So when we hear the word quart, we should think of the number 4. All right, so here's what we have. Here's our data set. It's already from least to greatest. If we count them up here, we have 2, 4, 6, 8, 10, and 12 numbers. So to find the median of this entire set, we're going to have to find the average, or the middle, of 71 and 74. So we'll add them and we'll divide by 2, and that will give us a total of 72.5. That will be the median. And the median here is actually going to be given the name of quartile 2. Okay, so quartile 2 is the median of the entire data set. So quartile 2 is 72.5. We found that because that was the median of the entire data set. Now we're going to break it up. Sorry, this should be written as the upper part. That was a typo there. Upper part. Okay, so now we're going to find the median of the lower part. So here's our lower part, all the blue numbers. We're going to find the median of that. So again, we have 2, 4, 6 numbers. So in order to find the median, we're going to have to find the average of 58 plus 63. We'll divide that by 2, and we will come out with 60.5. It's a very big decimal there, 0.5, so you can see it. Okay, and that is the median of the lower part, which means that is going to be our quartile 1. Quartile 1 is 60.5. And the median of the upper part, we're going to take all these green numbers here, find the middle. So again, we're going to have to find the average of 82 and 84. That one should be kind of common sense for us. The middle of 82 and 84 is 83. That's right in the middle. So that is quartile 3. So we're doing this in order to make our own box and whisker plot. So the box and whisker plot is going to be showing us where all of the data will lie. So we also need to know the minimum and the maximum value. So this is our minimum value. The minimum, that's right, min for minimum. And here's our maximum. Max or maximum is 86. Okay, so then when we actually go ahead and break it up, you'll say that the minimum we just said is 56. So the minimum is 56. Oh, there we go, 56. The maximum is 86. Quartile 1 is 60.5. Quartile 2 is 72.5. And quartile 3 is 83. So you do have to make sure that you put it on a number line and you make it accurate instead of just drawing the box and the whiskers. Draw it on a number line and make all of your tick marks for where all the numbers should be going. All right, so let's take a look at percentiles. So a percentile is a value that divides the range of a data set into 2 parts such that the part below the percentile contains a given percent of the data. So let's take a look here. We want to find the values at the 20th and the 65th percentiles for the values below. So here are our values. Okay, right now they are not in order. Okay, so you're going to have to actually, first thing you'll do is put them in order. You're going to order the values. So I went ahead and did that before I started the video just to save a little bit of time. Here is the correct order. So make sure you include all of them. There are 20 numbers here. 20 numbers here when I ordered them from least to greatest. Okay, so now we are going to find the 20th and the 65th percentile. So we're going to find the number of values that fall below the 20th percentile and the number of values that falls below the 65th percentile. So there are 20 values here. So what you're going to do for the 20th one is you're going to take 20, because this is the number of values in the data set. Okay, that's 20 because we counted them. There's 20 numbers here. That's for this one here too. So we're going to take 20 times, we're finding the 20th percentile, so times 20%, which is 20%, this is a times there, times 20%. 20% is the same as 0.2, and 20 times 0.2 is 4. So now what you're going to do is you're going to list how many values. We're going to count 4 values have to be below. So here's 1, 2, 3, 4. The next one is going to be your 20th percentile. Therefore, 47 is greater than 4 values, so 47 is at the 20th percentile of this data set. Okay, so the 65th percentile, we're going to take 20, because that's the number that we have in this set. That's how many values we have. 20 times 65%. 65% is the same as 0.65, and 20 times 0.65 is 13. So again, starting from the beginning, we're going to have 13 numbers below. So we're going to count that out. We'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 numbers. And then therefore, the next number is 87. So when we look at that here, 87 is greater than 13 values. Therefore, 87 is at the 65th percentile. And that's how we're going to be analyzing data with percentiles. All right, and finally here, this one is pretty easy as well. We're looking at an outlier. So an outlier is an item of data with a value substantially different from the rest of the items in the data set. And we're looking at an outlier because if there's one number that's a lot smaller or a lot bigger than the entire data set, then that's going to throw off all of your measures of central tendency. So again, we're going to just order them from least to greatest. And we can see here 56, 59, add 3. This is the same number here, add nothing. 59 to 65, add 6, add nothing, add 8. And then this one here, we have to add 25 to get to 98. So this one is a lot bigger than all of the other numbers here. So this is actually the outlier of this data set. And it just depends what you're looking at here. So it doesn't have to be a really big number. It could be a really small number. And either way, if it's a lot different from all of the data points, then that is the outlier. So 98 is our outlier for this set. And that will conclude 12.3, Analyzing Data. Thanks for listening.